Let us discuss Gauss theorem. What is Gauss theorem? It states that the total electric flux linked through a closed surface is always equal to 1 by epsilon naught times the total charge enclosed by the surface, or you can say the surface integral of electric field over a closed surface, that is the flux, is always equal to 1 by epsilon naught times the total charge enclosed by the surface, and this will be 0 if Q is outside the surface. So electric flux linked to a coil, electric flux linked to a closed surface is always 1 upon epsilon times the total charge enclosed by the surface. Let us prove it. So proof of this, let us consider here a charge Q and a surface over here. So if we consider a surface ds over here, so electric field will be again outward because it is plus Q. So the direction of E and ds is same. So E dot ds will be equals to E ds magnitude and cos theta. That means E ds cos 0, that will go to E into ds. The magnitude of E at this is R. If the surface is this, so again this distance is R. You just take the case of watermelon or the football, these hexagonal patches. If you see the distance of the hexagonal patch when it is here, it seems as R. But when you see the patch just in front of you, then you feel that like this. But again, it is on the surface itself. It is not in between or inside. So the distance R of each patch, wherever it is, so being seen, is always R. So don't get confused with this. So here, electric field E is KQ by R square. So now proof E dot ds is equal to mod ds into cos theta, which is 0. E ds cos 0 and is T ds. The value of E here at this point will be KQ by R square. So E dot ds over the closed surface will be equal to limit 0 to 4 pi R square. This is sphere. So the area of the sphere is 4 pi square. The value of this E is KQ by R square ds. That will be equal to 1 upon 4 pi epsilon naught K Q upon R square, and integral of ds will be s, तो 0 to 4 pi R square. ds का इंटीग्रेशन s हो जाएगा, तो लिमिट आएगी 0 to 4 pi square. ये सारा बाहर आ जाएगा because it is not depending on the ds. This can be treated as constant. So यहाँ हो जाएगा ये 1 upon 4 pi epsilon naught Q by R square into 4 pi R square minus 0, upper limit minus lower limit. So this will be equals to 1 upon 4 pi epsilon naught Q by R square into 4 pi R square. R square से R square cancel हो जाएगा, 4 pi से 4 pi cancel out, and it comes to be Q by epsilon naught. That means this flux phi equals to E dot ds over a closed surface is equals to Q by epsilon naught, which is proved. E dot ds over the closed surface is Q by epsilon naught, and this way you can just prove this Gauss theorem. So this will be a derivation where you have to state 1 mark for statement and 2 marks for proof. So the total derivation will consider 3 marks. Now, if this is the charge Q and this is the surface of radius R, so the flux will be equals to E dot ds will be always equals to Q by epsilon naught. Now, if the radius of this surface is doubled, that is 2r, so what will be the phi dash? So, electric field into area, so it will be doubled? No, it will not be doubled. Sometimes you are saying 4 times because area will become 4 times area. Radius is double, so it's not 4 times, neither it is 4 times, nor it is 2 times. See, E dot ds is always equal to Q by epsilon naught, whatever the charge is inside the surface. So previously it was the surface, and how much charge was inside the surface? Only Q, so it was Q by epsilon. Now forget about this surface and see, this is the surface this time. Whatever is the radius, it doesn't matter. According to Gauss theorem, it says the total flux linked through a surface is Q by, yani total charge inside the surface upon epsilon naught. That means again it will be Q by epsilon naught. Now, if I change this surface as a cylindrical surface, keeping the charge at the same way, so what will be the flux this time? Again, flux is Q by epsilon naught. If suppose, in case of the sphere, the charge was at the center, then flux was Q by epsilon naught. Now I shift the charge at some of the other point or other than the center. What will be the flux at this time? Again, according to the statement, the flux is always equal to Q by epsilon naught. So it will be Q by epsilon naught.